Hello, everyone. Welcome to this week's binary episode of the Day Zero podcast. I'm Spectre, with me is Z. And today we have a bit of a Samsung special, including a Samsung baseband bug, a radio interface layer bug, and a Mali GPU driver UAF. So literally all Samsung issues. But before that, though, we do want to bring up the Humble Bundle deal that was put out by Humble Bundle for the No Starch Press books. We talked about it a little bit on our Bounty episode yesterday, but there are some books that are relevant for binary as well. And just like yesterday, I'll let C get into some of the books that T finds interesting in the bundle.
Yeah, and like I said, or bouncing off that, the bounty episode, I think there's more books in here that are applicable to the bug bounty hunter, so you can kind of look on the bug bounty episode for some of that. But there are still a few books in here that may be interesting to some of you. The hardware hacking handbook. That was one book I had reviewed it, taking a look, and it kind of surprised me in terms of just it being comprehensive of a lot of the basic topics. It wasn't like absolutely everything, but it was a good breadth of topics. That if you're wanting to get in there, it seems like a good resource. Um, Not strictly binary, but serious cryptography is one of those books when you're looking for issues. You know, you sometimes do come across the binary type issue or the crypto type issues as you're looking at binaries. It's trying to deal with these crypto payloads, run into them. It's just a really good crypto book. Something that I kind of would have liked when I was getting started with doing like assessments that involved crypto. B Hoppers, thank you for the tier 1 sub. Um oh yeah, obviously hacking artifact exploitations in here. That's a book that's been in a bunch of these bundles. It's not really something I actively recommend, but it is one of those very early books. It has a very solid introduction to like basic 90s style exploitation. Hasn't been updated. A lot going on there. Practical malware analysis, similar. It's fairly old for a book. Well, I guess not old for a book, but it's old for like a reverse engineering book. It is more focused on like a practical and or like a dynamic analysis setup. Uh, is dated, but still has some good advice in there. But you'd probably want to update on the tooling side. Um, what else in here? Designing secure software is kind of an interesting one. I'm actually going to bring up the preview of it here. While it is, of course, about secure software design and kind of coming from more of the design and development side, it does do things like cover the low level coding flaws, as they call it. This isn't as solid of a book in that sense as something like Art of Software Security or Art of Software Security Assessment, but it is part of this bundle. Whereas if you want to buy Art of Software Security, it's a fairly expensive book. They do talk a bit about like how to actually do a security design review, how to actually do some of the auditing process. Um, so it is at least worth taking a look at. It's not like my active recommendation here, but it does seem like a good book. This is not one that I have fully reviewed. I've heard a few good things about it, so I'm going to pass it along. But it is worth checking out for just that side and for some of the explanations on the low level issues and more on the preventing them. So it gives you ideas for how to also discover, but not so much on how to test for them. Root kits and boot kits. Heard a ton about it. Had a lot of good recommendation, like people recommending it, but I have not read it. I think that's all of the kind of low level ones on here.
Yeah, I
And
just want to
X.
mention XCD. Yeah, I think we were about to say it's the same thing, but XCD80 mentioned that rootkits and bootkits is more about the introduction of UEFI and less about like writing rootkits and bootkits. So fair enough. I
Okay.
think that's one of the books that I'd meant to check out for a little while and then just never got around to it. But
Yeah,
that is a good
same.
distinction. So thanks for pointing that out.
Yeah. Kind of on the same front. Like it's one of those books I've heard mentioned quite a few times. And I kind of had the assumption that I would actually talk about doing like rootkits rather than going over the I guess, past and foundation to build upon. And don't get me wrong, that information can still be very valuable. It's not the focus I thought, uh, but still very useful. I could imagine in that active red teaming context and try to do something evasion and such. I could, or well, persistence, I guess, really for a rootkit or bootkit. Um, and still, I've heard a ton about it. I just haven't read it myself, so that is good clarification. But yeah, I
Cool.
mean, the bundle's also kind of one of the more expensive hacking ones. Should also mention Wiley has their bundle out too. It came out a couple weeks ago. I'm a lot less excited about that bundle. Um,
Yeah, the Wiley books in general are a little bit more like boilerplate. They don't tend to cover like a lot of what they cover. You can find pretty easily. I think like it's not really worth it the same way that the Snow Starch Press ones are generally, but it
I
is
mean,
worth shouting out that it's there and you can check it out and
there's
assess that for yourself.
one book in here that is actually kind of nice. Not so much like explicitly on the binary, but Alice and Bob learn application security. That is kind of the one book that I'd maybe call out from this bundle. Not that a lot of the other ones are bad. Like if you like Mitnick's books, Art of Deception's in here, and Art of Intrusion's in here. So like you get those sort of books in here. It's a lot more of a higher level, some that are more of a story basis, and things like that. But like basically just they don't feel like they're really technical books. They're a bit higher. One that did catch my eye open, not with the bug, but with stickers talking about AI attacks. Sounds like it could be kind of interesting. Like the sticker attacks that were used against AI. Probably seen some of the fun ones, like putting a pylon on like a self-driving car to just basically deny its service, stop it from going anywhere. And
Yeah, we
things.
used to cover those kinds of bugs all the time on the podcast at one point.
Yeah, that's
Well, a
why
lot of like
it's.
classifier fooling tricks and stuff like that.
Yeah, that's why it sounds kind of like an interesting book, but it's not really like a super technical book, or at least it doesn't read as though it is. Either way, I just figured I'd shout out the Wiley bundle. I do think you can get a good value out of the no starch one. The Wiley one is like half the price though for these books, so it's still worth at least knowing it's there if you want to take a look.
For sure. But yeah, just wanted to bring up the Humble Bundle deal for those who listen to the binary ones and might not catch our bounty episodes or whatever. And also just different relevant set of books. So yeah, like I said at the top of the episode, we have a bunch of Samsung bugs today. Well, actually, not a bunch. Only like three, so
We've got a
might be a bit
few.
of a shorter episode, but they're all Samsung, so we can keep that through line going. So two of the posts here are from Tasks. I think that's how you say it. I don't know, might be
Yeah, I'm
wrong.
not sure. Like TASZK is.
It's a little bit weird, but I'm gonna
Yeah.
go with Task, assuming the Z is silent. And yeah, so we'll start off with the baseband bug, and I'll let Z get into it.
All right. Yeah. So we actually have kind of two bugs from Task here that are they both chain nicely together. Um, and Rudimal says the Z spelled ZI is silent. I am definitely not silent, but um, go with this. Baseband bug is specifically, as it's kind of mentioning there, in the baseband chip itself that would be on a mobile device. They mentioned that this is mainly, or the implementation that matters here is mainly used on their Xeno chipsets, which you might know this one better than me, but I believe the Xenos is mostly kind of the worldwide release, and in the US, does Samsung switch their chip out?
Yeah,
Um,
Samsung uses Qualcomm in the U.S. Or North America rather, Canada, Mexico as well. It's mostly the international and European models that,
yeah,
that run the Exynos chips. Yeah,
yeah, that's what I was thinking. So that's one note, but basically, this is the baseband chip on those Xenos models, that with a vulnerability that can be used to achieve code execution. Unfortunately, we don't get all the details on how they can do the code execution here. But this is a fairly fundamentally straightforward issue, although there are a bunch of details around like how the cell networks work and all of that, because this is taking place with like the processing of LTE messages coming in. What do they call these things here? The traffic flow template information. I want to say information elements, but that wasn't. Yeah, information
Yep,
element.
it is.
So weird. I had to control F find it at the bottom of the page, but they're using it up here. I think they define it, but yeah, they do define it anyway. They get these messages in that enter this traffic flow template information element, and that contains a bunch of packet filters. Each of these like packet filter or the TFT is a collection of packet filters. Those get mapped onto a PDP context, which is kind of like how the cell service, when you allocate this PDP, it contains like all the subscriber information. So like your MZ number will be in that structure. The IP address they give you, information like that is going to be assigned there. It's kind of like your session with the with your service provider, as I understand it. And then inside of that, you can have these packet filters, which, so the TFT contains, I believe it's 15 packet filters, or can contain 15 of these PF descriptors. Yeah. It contains pointers to 15 packet descriptors. So each packet descriptor is allocated on the heap, but this initial structure just has the space for 15 of those. And then inside of each packet structure, you can have a number of component descriptors inside of there. And the components are where the actual like traffic mapping rules are defined, like source and source, destination, IP, port, and like the ranges that it applies to or whatever. That's all defined in these components. So as they're going through and all the parsing, they do have kind of a layout here of the structs as they reverse engineered 15 of those, and then 10 components. The spec for this is like you can have a maximum of 10 components inside of each packet filter. As it's iterating through, it does do the proper check on the number of packet filters that's going to read out the message. However, when it gets to components, it just iterates through the entire list of components, calculates how many components there are in the list. Just using this component count variable is going to iterate through incrementing that. Going to go through using that component count. It gets down to the bottom, whatever, but it'll allocate basically as many components as you give it, even though the structure itself only contains space for 10. It'll keep going, it'll access index 10, index 11, 12, 13, and writing in the pointer to the buffer that's allocating as long as you provide it inside the message. And a message itself can contain, or has space to contain, they mentioned roughly like 100 and I want to say 128, but that feels like I'm just pulling out the nice round binary number, but it's more than 100 potential components inside of one of these packet filters. So from
Up to
that, of course, it's
125. I was just
125,
looking
so
for it real quick,
close.
yeah.
Yeah, so basically, like, you're going to take this component and you're just accessing out of bounds, and it's just going to write these pointers to the data that the attacker controls, assuming the attacker is able to send these baseband messages or the cellular messages, writing the pointer. And that's kind of the end of the information we really get. They do go more into like the actual code flow that happens here, but we don't really get the exploitation, unfortunately. It is a pretty nice primitive to have where rather than controlling what the overflow data is itself, which can also be useful and is a more common scenario, you're getting it to write pointers to data you control, because quite often in structures, they're going to contain a pointer to data that wants to read. So this way you're getting it right, and you're getting it right from that, and you don't need to actually break like ASLR to do it. I don't see a really clear exploitation strategy just by looking at the structures that we've been introduced to here, which is the PF descriptor and the component descriptor. There's also the TFT descriptor, because I would imagine as it's going through here, there's a good chance you're going to be beside like the PF descriptor. There's a good chance that would overflow into these next allocated component descriptors, but it doesn't really have a lot there. But there is probably other code that's maybe going to be parsing that later. So you might be able to get something with the comp DAC because it is just treating it as a buffer. So I don't see it out this. They don't go into it, but they do assure us that they can get code execution. And with this sort of primitive, it's very believable that you would land with code execution there. So, fair enough.
Yeah.
But we don't have the information. I can't really even speculate without seeing a bit more about how it would get parsed, how that data blob gets parsed.
The other thing worth keeping in mind is this is being done on baseband, so it's a little bit hard for us to speculate too, just because it's going to depend on like how their heap allocator works and all the specifics of that and the environment. They might not have like a lot of the memory protections that you would expect on your typical processor, because it's the baseband, it's like lower power chip, it's doing one specific task, so it's not going to be as complicated. So that could have also like simplified the exploit scenario as well, but because of that, it also makes it harder to speculate on the exploitation strategy without knowing all the specifics. But yeah, when you get into like baseband and stuff, it's very interesting because it tends to be, from what I understand, I don't do baseband research, just to be clear about that. But from what I understand, like baseband seems to be a pretty soft target, pretty fun to exploit. Like you don't really have to chain a lot generally. It's just a target that's not easy for everybody to look at because sometimes there's obfuscation in play and there's a lot of undocumented stuff and you have to do a lot of reversing. And often you need specialized equipment as well to be able to do like thorough analysis of it. But
You need to
yeah,
be able to fake your own like cell tower to send the messages and have the phone connect to it, which
yeah,
can be questionably legal in some countries depending on your radio like rules regarding the radio bands and who
that
can
too.
use them.
Yeah, so the accessibility of doing this kind of research is a bit limited, but the targets themselves are pretty straightforward generally when it comes to exploitation. So
Yeah,
yeah, like you said, not too surprising they were able to get codec out of it.
yeah, and I think it's kind of an interesting area just because this is a side chip on the device. So even getting this code execution, this is code execution just on the baseband, which can be pretty useful if you're like analyzing all of the packets going out or something. Like that could probably leak a pretty good amount of information about a person if you just had that level of compromise. But usually what you want is to actually compromise the device itself. Um, and that's where like this kind of creates a really interesting attack scenario because you're not coming at the attack as like an untrusted user trying to do a local privilege escalation. You're coming from the baseband chip, and oftentimes with the kernel, it's more or less trusting what the baseband gives it. It's not necessarily doing all of the checks that it might do on like untrusted data. It'll still probably do some, but it is a bit of a weaker interface to have into the kernel and just a little bit different because of the direction that you're moving with the attack, which leads into the next topic from the same group here, which is a Samsung radio interface layer implementation vulnerability, um, which can be reached from the baseband sending messages to um, their radio interface layer and the IPC that it has set up. So leads kind of nicely into that. This vulnerability is, it's another buffer overflow. Honestly, pretty simple in this case though. The messages that, or I guess, you have this IPC protocol 41 SMS, and then just IPC RX incoming message. So as I mentioned, the RIL library, radio interface library, it just exposes this IPC setup so that the baseband can write messages onto this. I believe it's using an IO ring. Writes messages there and can alert the system that, hey, there's a new message, or the kernel can be pulling for it depending on the interface there. But it gets the message, and then the kernel goes now, and it's going to go and read it. And the CDMA SMS parser, CDMA SMS parser. I repeated that for those of you listening. Like that is the object name and then the function name. They both have the same name. You'll have
Well,
that,
it's a
which,
constructor, yeah.
yeah. Well, I'm not sure if it's necessarily being used as the constructor in this case. Anyway, whatever. It
Yeah,
lands
you
in
can
that.
see in the code snippet it is, right? It has this pointer in the first argument and
Oh
everything.
well,
It's yeah.
no, it's part of the object, so it can have this because there is a this because it is part of the object.
Yeah, but
But
for all intents and purposes, like it even if it's not
it's
technically a
working like
constructor in the
one.
C++
Yeah,
sense, it is. Yeah.
yeah, no, it's working as one. Yeah, they've got this function to initialize and copy the contents of that IPC message into a stack allocated buffer. The maximum size of an IPC message is hex 40,800 bytes, while the buffer is 1,096 bytes. So you can already imagine what's going wrong here. They copy the entire data from that into this stack object without any length checking. Just a nice mem copy. And therefore, you have a stack based buffer overflow coming from baseband interacting with the kernel. So a very straightforward buffer overflow. Um, we have Nick's Freak mentioned. I can't in chat. I can't believe these are buffer overflow vulns, and I mean we still run into a ton of buffer overflows. Just not doing boundary checks correctly. Like a straight up just stack based buffer overflow does feel a little bit more rare, seeing that in the kernel. But this is a really interesting and I guess a bit of a more unique case where you're coming from a somewhat trusted chip on the device already, providing this information to the kernel rather than it being a really obviously untrustworthy source. So I kind of get it. Like it's still not a good thing to do, and you still should be checking this. But I get kind of the mental place people might have been coming from. Um, and then on the baseband side of it, like the iterator there, that just should be checked, like plain and simple. But again, GSM or not GSM, but like the whole baseband and the cellular network feels at least a little bit more trusted. So again, I kind of understand why devs might not be thinking about the security as much because they trust it a little bit more to not be like malformed.
I
As
think it's
for
also a
the
code that people are generally scared to touch because out of
could
all
be,
the
yeah.
things on like a phone, you don't really want to break the cellular network capability.
And one of the other questions from Nick, or one of the questions from Nick's Freak is no stack protections. So the stack should have some protections here, but you do still have the ability to override like local variables even before you hit a like canary or something. We don't get exploit information here, so we don't know what strategy they actually used or what they had to deal with here. We only have the vulnerability itself, which they actually, I think they call it out here, could result in just denial of service in the Android context rather than actual buffer over, or rather than an actual code execution. So they're not getting like an LPE, just denying service. So that very well could just be because they are coming from the baseband, hitting the kernel, and then hitting these stack protectors and not able to get around that, therefore just crashing the device.
Yeah,
Which isn't quite the impact you'd want to have, but it's still fun to look at these attacks coming over. And um, oh yeah, one of the other things they call out here is side note: if the overflow value is large enough, there's actually another call that will happen that has a further stack overflow that gets triggered before yours. So lots of overflows here.
yeah. I do want to clarify one thing though. I believe you were saying that this was like allowed exploiting the kernel driver. As I understand it, the messages are received through the kernel, but they're attacking the user space RIL library.
That's a fair
So
shout. Yeah.
yeah, I just wanted to clarify that, just because the impact's not quite as high as it might initially seem. Although when you're talking about like denial of service and whatnot, it's you know whether you're doing it at the user space at the kernel level isn't super relevant at that point.
Yeah, I mean, actually, but that is a good point because, like, an actual exploit chain, like, let's say this was exploitable, that would be going baseband into radio interface service into that riddle service. And then from
Yeah,
there, you would have to go for a kernel privilege escalation. Yeah, for some reason, I had in my head this was driver, but yeah, it's got the shared library here. It's part of that service. So you would have a few more, like, privileged service access, but it is
yeah.
something different.
And I mean, it's fair because the messages are being like processed and coming in through the kernel, but yeah, it's just like an intermediary or whatever.
Yeah, it's not
Um,
exploiting the kernel.
yeah, but getting into an Android kernel issue, our last post is a report by Project Zero. It's a use after free in the Mali GPU driver, which is also used for Exynos chipsets. And yeah, so as the report says, in a later revision of Mali, revision 44, it became possible to free the context of a file while still having the file pointing to a KBase file. So basically, what they're saying here is whenever you open a handle into the GPU driver, you get a KBase file, and then that KBase file is attached to a context. And the context is like your handle into the GPU for doing operations in the GPU address space. Each context has its own view of the address space and things like that. And these structures have to be carefully managed. Like they have reference counts checks because obviously you can't have a context being freed while it's being operated on, or then you have a use after free in the driver, which is pretty much what happened here. In a later revision, so in earlier versions, the file and the context were more tightly coupled. As if you freed a context, the file was also not really reachable anymore. But in revision 44, that changed. So it was possible to free the context while still retaining that file handle. But what they note is that the KBase pull function for the pull syscall will connect the event queue of that context into the caller's wait table, but the teardown of the kernel context doesn't remove those connections from the caller wait table when it's tearing down the context. So context gets freed. Those waiting, the wait queue entry in the caller's wait table is left dangling, and you have use after free into vmalloc space. So fairly straightforward issue, and you can kind of see that too with the POC. They have the full POC here, and the POC is like it's like 20 lines of code outside of the macros and structure definitions. So fairly easy to trigger, and probably fairly exploitable too. Because whenever you have these kinds of use after frees, especially with the GPU, it's a very good primitive farm. So uh, yeah, little doubt that this would be pretty exploitable.
Yeah, it feels like something like it's almost a surprising bug again just to have. Like, of course, we see plenty of dangling pointer things there, but like having that kind of untracked wait table that holds on to the pointer just feels a little bit surprising of a structure of like a
Yeah,
way to implement this. But and yeah, I'll
yeah,
also kind of include the patch here. Patch isn't super interesting. They just move the event queue out of the actual context and into the K file. So basically making it last a bit longer, long enough for other things to clean up. But I'll include that if you want to at least take a look since we have
yeah.
it.
Basically just a order of operations change. Now this is fairly inconsequential, but it's kind of funny because this had happened with some of the other Mali issues we've covered in the past on the podcast too. The first comment by Jan Horn on this post says there was an issue with this bug report. ARM did not see my issue report and instead started addressing the issue when they received another colliding issue report. It's just kind of funny. It seems like ARM or like Samsung or whoever just because Mali is a little bit weird. So Mali is an ARM GPU, but it's also like Exynos is a primary manufacturer of ARM chips, so there's kind of like a collaboration there. But anyway, it seems like they have some like problems when it comes to receiving reports. Because I remember with some of the other Mali issues we covered, uh, the Project Zero researchers basically had to fight with like ARM to get it recognized as an issue. And it's just seems like maybe that still hasn't been fully resolved. In this case, it seems like they did like recognize it as an issue. It just kind of got lost and uh, the noise or
Well,
whatever.
they recognize
But
it as an issue because somebody else also reported it.
yeah, but it's funny to see that the bounty program, or rather the Vuln research program for Mali is still a little bit of a mess. But yeah, that's beside the point. Just something I noticed while we were covering it.
Yeah, I don't have a ton of like I don't have high expectations when it comes to the CPU manufacturer, that's ARM, but that also like Intel stuff. Like I don't have like obviously I haven't had any experience directly with them, but like their reputation on that front isn't the greatest. Both
You
in the
hear a
sense
lot.
of either ignoring things, but also just delaying and putting them off. Like even if that's not necessarily accurate, that's kind of the picture I get because of what I've been exposed to. They very well could be way better than I get exposed to, and I just hear all the bad cases. So I don't want to like hate on them or anything. Just my expectations aren't super high.
Could be an exposure bias, but
Yeah.
it is a general sentiment among the industry. I think I talked about it before, but if you want a good like video talking about the players in the CPU industry and how they handle security reports and whatnot, you should check out the keynote of the Hardware IO USA from this year. Uh, there's some
Okay.
funny
Do you know
funny
what the talk,
stories in there.
like the actual title was?
Uh, I think it was it had side channels in it, I think.
Right.
Sorry, I'm just looking it up really quick because I do want to
Yeah,
get the
I
name.
was actually trying to find the link to it. But yeah, I don't necessarily see one
I'll be able to
here.
get it in a second. Yeah, so the microarchitectures that I saw and the ones that I hope to see one day, to one day see, by Rodrigo Branco. So yeah, that's the keynote
Uh,
that I was referring to there.
do you have the link?
Yeah, I can send it to you.
All right.
Let me just send it.
Or open
There
it
you
in the
go.
browser.
Yeah, I could do that too, although sometimes that doesn't work for me. Let's see if it'll work today.
Yep,
Did
I've
it come
got
up?
it. Yep.
Okay, cool. Yeah, so there's a fun talk for anyone who's interested in the CPU side of things. But yeah, so that's all the vulnerabilities that we have for this week. We do have a shout out, which I'll let Z get into here, and then we'll wrap it up.
Yeah, and just this one shout out from ZDI, a detailed look at Pontone Automotive EV charger hardware. And it's what the title says. It's a breakdown and look at some of the charging hardware, some of the chips involved, and all of that. Seems like it's good background if that's an area you want to get into. So I just want to give it a shout out. It's not an area that I plan to get into anytime soon, so I can't say it's great or not, but it did look interesting and it is coming out of ZDI, so reasonable expectations there. I have higher expectations from ZDI than I do from the CPU manufacturers.
Fair enough. All right. So yeah, that's all the topics we have for this week. So as always, thanks goes out to all of you for listening. If you want to go back and check out past episodes, you can find them on YouTube, Spotify, Apple Podcasts, and more links on Anchor, and also recent episodes on Twitch. Feel free to join the Discord and follow us on Twitter. Links to those are down below or in the chat. And with that said, we will see you next week.